This is a video regarding some probability examples using the multiplication rule, and these examples are pretty quick and easy in general. The two things that you want to think about is, or before you do your calculations, whether or not your cases, your events are independent or dependent. And independent events, you know that they are independent if one event does not affect the outcome or the probability of another. If they're dependent, then one event does affect the probability or outcome of another. And I'll, of course, do examples of both. Another situation is, if you think about it, let's say you have a bag of marbles. Let's say that I want to pick two marbles out of that bag one at a time. And I go to the bag and I pick out a marble and I keep it out. And then I go back and I pick another marble. Obviously, I'm affecting the amount of marbles in the bag. Versus if I go to this bag of marbles and I pick a marble out of this bag. And then I put it back and then I pick another one out. For the second marble that I choose, I still have the same amount that I started with. So in that sense, and again, I'll do examples. We might call with replacement and without replacement. So with replacement means I'm inputting and putting back that marble, for example, before I choose another, and I'm not affecting the second outcome. So that's an example of an independent case, or independent events with replacement. If I keep the marble out of the bag or whatever, and then go and pick another marble, I'm affecting the amount of marbles in that bag. So the second event is affected by the first. That's an example of dependent events. So without replacement is an example of dependent events. So all right, we're going to do an example of both of these, and let's just do a bag of marbles. So I have a bag of marbles, and this is just one application of this. I have a bag of marbles, and I want to, let's just select 3 marbles from this bag. And the moment that I select more than one, because I'm selecting 3 and I'm not selecting 1, I automatically know that I have to use the multiplication rule. So that's a way to determine that you are using or need to use the multiplication rule if you have more than one that you're choosing. And then, of course, again, we have to ask ourselves, are the events independent or are they dependent? So if I'm selecting 3 marbles, I have 3 events. Now let's just say that I have in this bag of marbles 10 blue marbles. Let's say 6 purple. And let's make it 3 green. Okay, they're my favorite colors. I want the probability that, let's say, all 3 marbles are blue. And blue is my favorite color. So let's do, in this case, with replacement. So that means that I'm going to this bag of marbles, I'm picking a blue, I'm putting it back, then I'm going back to the bag, I'm picking another blue, putting it back, right? I'm replacing it every single time. So that means that I have independent events. So all 3 events are independent events. Now, because it's the multiplication rule, we're going to multiply. How many values am I going to multiply? I'm going to multiply 3 different values because I have 3 different events. The first parentheses represents the first event, and the first event is I'm selecting a blue marble. What is the probability that I select a blue marble? Well, I have 10 blue marbles out of a total of 19 marbles. Now, what do I do with that blue marble? Do I put it back? If I do, I still have 19 marbles, and I still have 10 blue marbles. So the second event is to select the second or another blue marble. Because I have the same amount of blue marbles, and I have the same amount of marbles, it's still 10 out of 19. I put that marble back. Again, the third event is selecting another blue marble. I still have 10 marbles in the bag. I still have 19 marbles. 10 out of 19 is the probability of this. Now the probability of all 3 happening, right? The probability of selecting all 3 marbles with replacement is the product of all 3 of these fractions. Now, because we're multiplying, these numbers will get large very quickly. If I'm multiplying across the top, you have 10 times 10 times 10, 19 times 19 times 19, or the same fraction multiplied by itself 3 times is 10 over 19 to the third power. If they're independent events, I can simplify it this way, but a lot of times you're going to represent your final probability in decimal or percentage form because there's a lot of numbers, right? These numbers, they grow very fast, 19 times 19 times 19. So in your calculator, you're going to do 10 out of 19 and raise it to the third power, and you're going to get approximately 0.146. So this is the probability in decimal form that I go to a bag of marbles that has 10 blue marbles, 6 purple, 3 green, total of 19, and I go and I pick a marble that's blue, put it back, pick a marble that's blue, put it back, and then pick another marble that's blue, and then put it back. The probability of that happening is 0.146 or 14.6% chance. Now, we say that that's pretty likely. Anything above 5% we consider likely. And I would say that that makes sense because the majority of the marbles in this bag are blue. So it's probably more likely that I'll get more blue marbles than other colors. Okay, but in this case, 14.6% chance that I'm going to pick a blue, a blue, a blue if they're independent events and if I'm replacing each. Okay, what happens if I do the same thing? I have a bag of marbles, the same amount of each color. I want to select 3, but now I want the probability that all 3 marbles are blue without replacement. So now what that means is that I'm going to this bag of marbles, and on my first choice or on my first pick, I'm picking a blue, but I'm keeping it out. I want to keep it next to me. Then I'm going back to this bag of marbles and I want to pick another blue. And then of course I'm keeping that next to me, and then I go back again and pick another blue. Obviously, because in each case I'm picking another blue marble and I'm keeping it next to me, I'm changing the amount of blue marbles and I'm changing the amount of marbles in the bag. So I'm affecting the probability of the next event. I have dependent events. They're dependent. Again, because I want to select 3 marbles, I'm going to have 3 different cases that I'm going to multiply. I'm choosing more than one. It's a multiplication rule. And the first parenthesis is going to represent the first event. And the first event is selecting a blue marble. So again, I have 10 out of 19. That's the probability of selecting a blue marble on my first event. But now I keep that marble next to me. And so now I only have 9 blue marbles in that bag. And I only have now 18 marbles in that bag. So if I want to select another blue marble, that probability would be 9 out of 18. 1 less blue marble, 1 less total marble in the bag. So now the probability is affected for the second event from what happened in the first. And that's an example of dependent events without replacement. Again, I have to pick a third marble, but the first 2 marbles I'm keeping next to me. So now I have 2 less blue marbles, and therefore I have 8 blue marbles out of 2 less total marbles, 17 total marbles. This is the case, of course, the last event, where I kept the first 2 blue marbles next to me, so I have 2 less of each case, 2 less blue, 2 less total marbles. So the product of all 3 of these is the total probability of me going to this bag and picking 3 marbles, 1 at a time. They're all blue, but I'm not replacing them with each event. And we can't use the same trick that we did in the last example where I raised it to the third power because each of these are different. And if you're doing this, in your calculator, you're going to do 10 times 9 times 8 over 19 times 18 times 17. Obviously, these numbers are going to increase very quickly. So we're going to represent our probability in decimal form or percentage form. And again, put parentheses around 10 times 9 times 8, and then we're divided by parentheses 19 times 18 times 17 if you're doing it in your calculator. And you should get, I'll round it to the nearest thousand, 0.124. So this is the probability in decimal form, and in percentage form, 12.4%. So you can see that in this case, the probability decreased, right? The probability that I selected all 3 blue marbles with replacement, where I was putting them back every time, was 14.6%. And in this case, if I'm not putting them back, and I pick 3 blue marbles, my probability decreased, which would make sense because I'm decreasing the amount of blue marbles in the bag. So the likelihood of me getting a blue again every time would probably go down. That total probability of that happening would go down. Now I want to just do one more example just to show you a different case. Find the probability if I select, let's just select 4 marbles. If I select 4 marbles, I want the probability that I get, same scenario, I have blue, I have purple, and I have green. I get, let's do first a blue, 1 blue, then 1 green, then 1 purple, then 1 blue. So I go to this bag of marbles, I'm selecting 4 marbles, and I want it in this particular order. I want to get a blue, and then a green, and then a purple, and then a blue. And the order does matter. Now because again I'm selecting more than 1, you have to ask yourself, well, first of all, it's the multiplication rule. Are they independent or dependent events? And I have 4 total events for this case. And I'm going to tell you guys that I'm going to do this without replacement. So that means that they are dependent events. And I have 4 marbles that I'm choosing, so I have 4 events that I need to determine. The product of these events would be my total probability of this case. I'm using the multiplication rule. For my first event, I want to select the blue. Select the blue marble. And again, what did we say? We had 10 blue marbles out of 19 total marbles. So the probability that I select a blue first is 10 out of 19 again. Now for the second marble, I want to get a green. So I'm selecting a green, but I didn't put this blue one back in the bag. Now, the fact that I kept the blue one doesn't affect the amount of green marbles, but it does affect the overall amount of marbles. So instead of 19 marbles, now I have 18 marbles. But I still have how many? 3 total green in the bag. So the probability of me picking a green after I picked a blue one and kept it is 3 out of 18. Now the third event is to select a purple. And again, I'm not putting the blue marble back, I'm not putting the green marble back. So instead of 19 marbles, I now have 17, 2 less. I'm keeping the first 2. But the marbles that I picked, because it was a blue and a green, does not affect the amount of purple, so I still have 6 total purple marbles. So my probability of selecting a purple is now 6 out of 17, after selecting a blue and then a green and keeping them. The last one is another blue one. I want to select another blue one. And again, I'm keeping the blue, the first blue, I'm keeping the green, and I'm keeping the purple marble next to me. So now I only have 16 marbles in my bag. And I wanted to choose a blue marble, and I do have less blue because remember, the first marble that I chose was blue. So instead of 10 blue marbles, I now have 9 blue marbles. And the product of these 4 events is my total probability of this case. The probability, I go and I select a blue, a green, a purple, and then a blue without replacement in a bag of marbles that has, this many blue, this many purple, this many green. So if you're, doing this on your calculator, you're 10 times 3 times 6 times 9 on top, all over, 19 times 18 times 17 times 16. And then again, we're going to put that in 10 times 3 times 6 times 9 divided by 19 times 18 times 17 times 16. We're going to put that in decimal form. Typically, probability, we round to the nearest thousandth, because a lot of times when we go into the percentage form, we want it to the nearest tenth of a percent, and this is the tenths place. So when you move the decimal 2 places to the right, it lands here. You want that guy there to represent your tenths place in percentage form. So it is 1.7% chance of me going to this bag of marbles and selecting a blue, and then a green, and then a purple, and then a blue, in that order, without replacing any of the marbles that I select. Which is unlikely, which makes sense just based on the situation, right? Probability should technically make logical sense to you. Does it seem like it's, a high case or a high probability? Does it seem like it would happen? Does it seem like it won't? The probability, the value should correspond to what you naturally would think.